Hello everyone, this is Vikram and welcome to my channel. In the previous video, we talked about how to create a simple Go program, build it and run it. We also understood the difference between Go run, Go build and Go install. In this video, we will see how to organize your Go code into packages and modules. What is the use of packages, how to create a module. Even though these are very advanced topics in Go, it is better to understand these concepts at the beginning of your learning experience. This will help us a lot in organizing Go code and also, consuming others Go modules or packages. So we'll understand how to create packages, how to create modules, the difference, what is use of go.mod file and go.sum file. And we'll also see some of the GitHub repositories, that will clearly explain the usage of packages and modules. Of course, we are not going to write a complete package or a module, but we are going to just take some examples and understand how these packages and modules are used in Golang. Go packages. So basically, you should organize your Go code into packages, and packages are a fundamental aspect of code design, Go language design. So this package provides a way to structure and manage your Go code in modular and reusable manner. So for example, in the previous video, we talked about the use of package main. So the package main is basically used if you want to create executables in Go. Let's say I'm not creating any executable, right? I'm just creating a package. So that serves as a dependency for other Go programs. So in this case, I might use a different package name, and inside each package I can have multiple Go files. So for example, if you see, there is this folder. Of course, this folder can be a module. I'll show the difference. But if you see inside this folder, I have a calculator folder. So inside this calculator folder, I have multiple Go files. And again, I have utils. Again, this is a folder, but we call it as a package. Inside that, you have a single file. So here you can take calculator as a package, and inside this package, you have multiple Go files, and all these Go files belong to the same package. Let's say, if I open add.go or subtract.go, so you will see a package with the same name. Let's say package math and package math in both add.go and subtract.go. So which makes these two Go files belong to that calculator package. Now this calculator package can be imported into other projects, consuming the variables or functions inside these two Go files. And every Go file should belong to a package, right? So for example, we have package main. Inside that package main, you have function main. So that serves like an entry point. And this package main, make sure that this whatever Go program that we are developing is an executable. Okay. So every package, every file inside Go should belong to a package. It can be package main, or it can be any package like package calculator, package utils, package DB connections. It can be anything. I'm also going to show some, example repositories. Okay. And here main package is a special package in Go, and that is used for creating executables in Go. So whenever you have a main package and if you just run go build, so you're going to get an executable. So without this main package, you cannot just create any executable. So that's the reason why whenever you're building any applications, you need to have a package main and an entry point called function main. So that serves like a starting point of your complete application. And here the main package cannot be imported by other packages, right? So if you have a package calculator, I can use it within the same application, or it can be imported into other applications or projects that are being developed in Go. But, the package main, which is available within a project, cannot be, imported by other packages. And it is just like an entry point to your application, right? And it is always a good practice to declare this main package files, whatever main package files that you have at the project root folder. So for example, I have main.go. So this main.go, even though I named it as main, you can also use app.go. But if you open app.go or main.go, you should have this package main. So that makes sure that the Go program belongs to that package main. Okay. And of course, you can have multiple files that belong to the package main, but only one Go file should have the function main within those packages. Let's say there is this package main. Okay, I have two files called main.go and let's say something like db.go. So among these two, only one package that belongs to this main, one Go file that belongs to the main package should have the main function. Either it can be in main.go or it can be in db.go, and they both belong to the same main package. Okay, and how these packages can be imported by other projects. Okay, so if you see our basic Go program, right? So we used import fmt. So this fmt is a standard package, and your Go tools knows how to pull this package. And of course your packages can be hosted in GitHub repositories as well. Okay, and if you see this import, so this is importing from a GitHub repository, from this domain, this user or the organization, and this is the repository name, and this is the package. So this is your actual repository. Under this repository, you can have multiple packages like net, db, or it can be anything. Okay. So here I'm importing from a GitHub repository. Similarly, if I'm simply using import fmt, so this will be pulled from a standard location. Go tools knows how to pull the standard packages like fmt. Okay, so this is how you use external packages. For very small programs, you ideally will not require, any packages. Let's say I have a folder. Inside that folder, I can simply write main.go that belong to the package main, and I can simply build my executable. So it is not necessary to create, a folder called main. Under that, I can, there is no need to put main.go and all those, structures. If it is a simple program, you can simply start with a single file. No need to create that directory structure or packaging structure, anything like that. Okay. Now let's see what are the contents of this my app. So I have my app. So inside this my app, I have main.go, and I have two packages inside it, calculator and utils. Okay, so if I see main.go, okay, so this is main.go. So what this main.go is doing is it is actually importing a standard FMT package, a calculator package, and utils package. But from where? It is taking from my app. So this is my app. So how does this my app gets resolved here? This is not a GitHub repository like a github.com, something like this. So which means your Go tools will basically try to find this my app within the Go path, and inside that it will try to find a calculator folder. Okay, so you have my app and calculator, and also you're trying to import my app and utils as well. And this main.go file is belonging to this package main, and also this has function main, which means we are trying to create an executable. So whenever you build this Go the project, you're going to get an exe file. And coming to this calculator, so calculator has add.go and subtract.go. So if you see, these are two files, and these two files belong to the same package called calculator. So the reason why I have included two different Go files is it is just for my organize for it is just for organizing my Go code. If I want, I can put both add and subtract functions within the same Go file, and I can simply call a single file as some calculations.go, something like this. I can use it, but in order to better organize my Go code, I broke those two functions into two different files, but make sure that they both belong to the same package. And now I have utils. Utils has validation.go, and it belongs to the utils package, right? So utils package means this package. Inside it, it has just one function. And if you see, none of these three files has main function, because these are just like packages which are being imported by your application inside this main.go file. That's the reason why they will not have any entry point to make them an executable. Our entry point and the package main makes this particular main.go file as an entry point, and also when you build it, it becomes an executable. And if you look at the function main, here I'm just printing hello from app. And now what I'm trying to do is I'm trying to add 5 comma 3. But where exactly is this add function defined? So this add function is defined in the calculator package. That's the reason why I'm importing the calculator package. So within this calculator package, it will first try to find the add function. But where exactly is the add function? Add function is in add.go. Subtract function is in subtract.go. So you don't have to, mention in which file this add function is available, because all these files belong to the same package. So you just look for the add function from a package, not from individual files. Similarly, we are trying to call the subtract function from the calculator package. And here, we are calling this validate function from the utils package. That's the reason why we have to import the utils first. So this is the way of organizing your Go code into packages. Of course, it might look complex as of now, but as we proceed with understanding how to write and organize Go code, it becomes pretty easier. Now coming to the Go modules. So what are modules? So we know that a collection of Go files becomes a package, but here collection of Go packages becomes a module. So a module will have many Go packages here. Now if you look at this my app, so this my app, currently it is not a package. Okay, so this is just like a normal folder. Within that normal folder you have two different folders, we call them as packages. But currently this is not a module, even though you have two different packages. Okay, so what makes a folder as a module is having this go.mod file. Okay, so what is this go.mod file? How this is created is, so whenever you wanted to create a module. Okay, so let's say this is the folder structure I have, because I wanted to make this as a module because I have couple of packages inside it. So if I do go mod init and give the name of the module, this becomes a module. Okay, so go mod init, we are this is just like git init or docker init commands, right? So git init will create will initialize an empty git repository, or if you already have the source code, it will just try to track it. So similarly, go mod init, it will create a module and make sure that whatever name that you provide to the module, so it is like a GitHub repository. The reason why we are naming this module with the URL of the GitHub repository is so that the others can use your module, which means they can call all the packages within your module. So if you simply use go mod init and name of the package as, let's say, my app, so this becomes a local module which cannot be shared with anyone. I'm also going to just prove it. So whenever you initialize a module, so a file called go.mod file will be created. Okay, so this file will be at the root of the repository, and it will have the contents of the module name and the Go version which is used to create this module. Okay, so basically it will also have other things, but the few things, the first few things are the name of the module and the version of the Go which is used to create this particular module. Okay, now let's say I have a simple Go file. Okay, so just ignore this for now. So I just used an import FMT, and I'm just printing something. But here I'm also importing an external package called code package. Now, what is this code package? So this is basically a dependency for my project. Okay, without this dependency, I cannot use any functions or variables within this package. And if you see within this println, I'm actually calling that package and a function called go within that package, which means this package should be imported. Now, how does my Go project track these dependencies? Okay, so here basically these dependencies should be part of go.mod file. Okay, so go.mod file will maintain all the dependencies of your project. Okay, but should I enter this information manually? No. So once you have any dependency mentioned in your Go files, just do go mod tidy. So what this will do is this will first check your go.mod file and all your dependencies mentioned. If anything are missing, so go mod tidy command is going to enter these dependencies and their versions into your go.mod file. So in this case, if I just do go.mod tidy, if you compare to the previous go.mod file, we don't have any information about the external dependencies. But if you see, once you do go mod tidy, so it is saying require this code package of this particular version, and also all the dependencies required for the code code package to work also gets mentioned in this go.mod file. Okay, so this go.mod file will track all the project dependencies in a single file. Okay, and what will happen to all these dependencies when you try to use them is they gets downloaded from the internet or from the source, and they get moved to the pkg directory under mod folder. We already know, so GoPath has three directories: src, pkg, and bin directory. So whatever packages that you used gets downloaded into the pkg directory under your go path folder. Okay. Now there is another interesting file that gets created. So whenever you try to, just clone or just pull all the project dependencies, right? So whenever you do go mod tidy, okay, so that will just update your go.mod file with the dependencies, and also it will pull all the missing dependencies. It also creates a go.sum file. So this go.sum file will hold all the checksums of the dependencies. So why these checksums are, required? Let's say, I am developing a go project, and I have five different dependencies, right? And I have cloned all these five different dependencies. Okay, and this go.sum file is created. So this go.sum file will have the checksums. Okay, so that will point to the, that will just that are just calculated for all the dependencies. Okay, now what is the advantage of using this is, so in case if I have to share this go project with someone, okay, so they also get access to go.mod and go.sum file, because go.mod and go.sum files should be checked in into the repository where you're maintaining your project, which means if someone clones your repository, they'll also get access to go.mod and go.sum files. Okay, and this sum files, so it will have the checksums of all the dependencies. Now, when they try to pull all the dependencies, because when they clone, they will not have all the dependencies that are mentioned in go.mod file, right? They have to download it. So usually they do go mod download or go mod tidy. So that will clone all the dependencies. Now, once they cloned, your Go tools will also calculate the checksum of all the downloaded dependencies. Now, if that checksum doesn't match the checksums present in go.sum file, so Go assumes that someone corrupted those files when you're trying to download, or those files got corrupted when they have downloaded. So Go assumes that there is some issue with the downloaded packages, because the checksums that are mentioned in go.sum file are not matching with the checksums that Go tools calculate once they download the dependency. So this is just like a security measure, so which will help you, identify if you are using proper Go packages or not, or whether those packages are corrupted or tampered when you try to pull from the internet. So this is the reason why go.sum file is um, used to, basically check the integrity of your dependencies. Okay, and make sure that you are using proper Go packages. Okay, so finally, so we have some commands. In order to create a Go module, you just do go mod init, name of the module. So when you do this, you will also create go.mod file. Okay, and let's say you have go.mod file with all the dependencies mentioned. Okay, so you can just do go get and then the name of the package. So it will download the packages for you. You can also download a specific version of a package using go get name of the package and at the rate of the version tag. Okay, you could also do go mod download. So what this will do is this will actually read the go.mod file, find all the dependencies mentioned, and then it is going to download all the dependencies. Okay, and you can also verify whether the dependencies actually match your checksum using go mod verify. That is also there. And if you want to see the dependency graph, okay, you can also do go mod graph. So these are not used, we will not use them maybe during the initial few videos, but it is good to know all these things. And I'm also going to show you one GitHub repository So where we will see how to use Go packages and all the modules. Okay. This is our Go program from our previous video. It is just printing hello world string. So what exactly this is doing is this is just calling println function from the FMTP package. That's the reason why we imported FMTP package. And this particular Go file belong to the package main so that we can make an executable. And so for adding extra packages, I'm just going to refer this tutorial from the official Go page. If you go to go.dev/doc tutorial, you're going to find this getting started section. So where they actually created a folder called hello, and then they created this simple hello.go file. But the thing is, they also created this, so basically as an, module. Okay, so what we are going to do now is we are also going to convert this as a module. So I'm just going to open the terminal, and then I'm just seeding into that particular folder where I have this app.go file. Okay. And now inside this src, I have my first app. So this is just a folder name. So what I'm going to do is I'm just going to initialize this, as a module, and I'm going to use the same folder name as the module. So I'm going to explain why this is required later. So I just created or converted this particular folder into a module. And then if you try to open go.mod file, you will see that it has the name of the module and the version of the Go that is used to create this module. And now what I'm going to do is I'm going to refer this particular tutorial and add this particular code package. So I'll go to my app.go file and I'll add this extra code package. And then what I'm going to do is I'm going to just call fmt.println. So inside this println, I'm just going to call that code package. Inside this code package, you will basically have a lot of functions. So I'm just calling this go function. So I just have to open and close it. So it becomes a function call. And the reason why this is throwing an error because we did not actually download this particular package. So for that, what we have to do is we have to use go.mod tidy, because if you look at the go.mod file, it is not mentioning any of the dependencies required for your app.go file to work, because app.go file has this code package. If I simply do go.mod tidy, so your Go tool will basically find all the missing dependencies and then download them, and also it is going to update your go.mod file so with the required code package and its version, and also any of the requirements for the code package to work. And if you go back to your app.go file, you will see that basically that error is gone. Now if I have to run this Go file, I just have to use go run app.go, and then this is going to just run hello world as the first print function, and the other function, it is just calling the go function from the code package. So it is just printing something. We don't have to understand anything about that. But if you want to know more about this code function, you can just go to these packages and then search for code package. I'll just search for code, and this is the package. And if you see, it has 4 different functions like go, glass, hello, and opt. If I just click on go, so it is basically returning an optimization truth. Sorry, not this. Returns a go proverb. It is just returning something. Okay, so I can also go back to the source files, view all the source files, and then see exactly what this is, doing. So if I just open this go file, you can see, we called this go, basically go function. So the go function returns the string like don't communicate by sharing memory. And if you go back to your program, you can see the same data that is being printed. So this is a very basic introduction to the modules and how to use the packages. Now what we will do is we will try to see other package and then see how we can share that package, or how we can share that module inside your Git repository. So for that, I have this my calculator app. Okay, I'm just going to show in the file system as well. So basically I just copied it outside src. I'm just going to move it into the src. Okay, so inside the SRC, I have this calculator. Inside this my calculator app folder, I have that main.go file. Okay, so here, it has some imports. So for this, let me just change some imports for time being. So let's say my calculator app slash calculator. I'm just going to explain so why I had to take these imports. Let me just save this. Okay. So if you see there are a lot of errors for now, just open main.go file. So inside this main.go file, actually it is trying to import two different packages called calculator and the other one is utils. And if you look at the first part, basically this is just like the module name. Okay, so the module name, inside that module name it will have calculator package and utils package, and we are actually using these two. And if you look at this calculator package, I have two files, add.go and subtract.go. And if you look at the both the files, it has add function, subtract function, but they both belong to the same package. Okay, so we can have multiple Go files belong to the same package. And I just added to that, calculator folder, which is your package. And then inside utils, I have validation.go, which belongs to the same utils package. Okay. Now the problem here is if you look at this main.go file, it is actually trying to import calculator and utils packages, but this path is not known because this path, my calculator app, is not yet known to Go path because we did not actually convert this particular my calculator app as a folder. So if I just cd into you know my calculator app, and if I just initialize this into go.mod init, initialize this as a module with the same name called my calculator app, then what will happen is Go is going to find my calculator app, which is a module. Okay, this module Go is going to search inside the Go path src. Already inside the Go path src, if you see, I have that particular module name folder with the same name, which means that error is now gone. And inside main.go file, if you see, we are trying to import calculator package and utils package from my calculator app module. Okay, so this path is also known to Go path because inside Go path src you have my calculator app folder. Inside that you have calculator and utils both, which means now we have now resolved this issue. And now I can run go run main.go file, and then we are going to just get some output because here we are just printing some text, calling add function, subtract function, add 5 comma 3 is 8, subtract 8 comma 4 is 4, and some validation which is actually returning as true. So we don't have to understand all these of now. I just wanted to show you how to create modules and how to use packages. Okay, so this is one example. But the problem here is, this particular module is not being shared with anyone because this module, my calculator app, is local to my machine. So no one is going to, use these import statements because they will not have my calculator app folder, within their, local path. So for this, in order to share it with, others, what I'm going to do is I'm just going to go to my, GitHub repository. And then what I'll do is I'll create a new repository, and I'll call it as, Go calculator. And then I'm just going to make it public and then just create a repository. Okay. So now what I can do is, in order to share this particular, um, basically this module with others, I have to convert this into a module in such a way that the module path is nothing but my GitHub repository name, so which is till here. Since I already have this go.mod file which is using a different module name, all I'm going to do is I'm just going to delete this and then initialize it again, call go.mod init. And then I'll just say this, this module name is nothing but it's a location to my repository. Okay. And now, your module is in this repository. So inside this module, you should have calculator and utils, which means, so now my calculator and the utils packages should be coming from this particular Git repository. Okay. And again, if you see this, we don't have these calculator and utils packages yet in the GitHub repository because we did not actually push our source code. Now, what I'm going to do is I'm just going to do go mod tidy in order to pull all the dependencies, but these dependencies are not yet available within the Git repository, right? So for this, what I'll do is, I'll just initialize this as a repository by doing Git repository by doing Git init, and then add all the files to the staging, and then make a commit, which is an initial commit, right? And then I'm going to push it to the repository. But for that, I need to add this origin for my local repository. Okay, I just added it, and then I'm just going to, push it to the master branch. So git push origin master branch. So all my entire module is now in this particular repository. And if you see, I have calculator and utils both. And if you look at the go.mod file, okay, it is, the name of the module. Okay. Uh, and I can now do go mod tidy. Okay, so nothing is going to get downloaded. But if you still see, it says could not import this particular package. But if I try to do go run main.go, it is going to work. But how this is going to work, but I'm not able to resolve this issue is, see this, till this go calculator, it is nothing but my the module path. Okay, so this module path should be inside SRC, but inside the SRC, if you see, the name of the folder is my calculator app. It is not this full name. Okay, so for this, what I have to do is, basically I have to, create this path under the SRC. So what I'm going to do is I'm just going to go one step back into the SRC, and then I'll simply do mkdir-p, and this is what I'm just going to create. Now if you see, I have github.com. Under that, I have my username. Under that, the go calculator. So for this, what I have to do, I have to move the entire contents of my calculator app. I'll just cut everything and then go to github.com/ my username / go calculator, which is nothing but my module name. And then I'll go back to the SRC, delete this my calculator app. Now, if I go back, and then let me close all the active files. And now if I just, go to github.com/ my username / go calculator, and if I try to open main.go file, now that error is gone because this calculator and this utils are from this module. And if you see, I perfectly created that folder structure, which is nothing but the module name. Inside that module, I have calculator and utils that belong to the you know that particular module. Now if I run go mod tidy, so if I have to just go back to github.com and all those things, and then if I do go mod tidy, you can see that anyways all those dependencies are already downloaded. You can see my application will work perfectly. And also, since I just shared my entire um, what do you say, this entire repository, which is public, so anyone can use it. And also what I can do is I can simply, if you want, I can just delete this go.mod file, and again I can just create it using the same go mod in it, and the name of the complete of the repository, and then use go mod tidy. Okay, so it is going to create that same go.mod file. And so earlier we just if you see, we have did go mod tidy, and it has actually downloaded everything. Okay, so which means everything is now working fine. Okay, and there is one more example that I wanted to show is, so this is from Docker samples. Okay, so inside this Docker samples, you have build me repository. Inside this repository, if you see, so it has go.sum file, go.mod file, and then there is the CMD. So inside the CMD, you have client and server. So these are codes for two different applications. One is client application, So the other one is server application. So if I just click on client application, if you see there is this main.go file. Okay, so let me basically open it in VS Code by simply appending one s after GitHub. Okay, so this is going to open in browser VS Code. Okay, now if I just open client, there is this main.go file. Okay, and then this main.go belongs to package main, and there is a function main. Okay, so this is used for creating an executable, and we have request.go. This also belong to package main, and UI.go. This also belong to the same package main. But if you look at all these three files, only one file should have the function main, which serves like an input. So I can build the client separately. There is also server has main.go. This belong to the main package. Translate.go. This belong to the main package. But if you look at main.go, so this only has the function main. This serves like an entry point. Now your server is actually importing this library or the package and one more package. And similarly inside client, if you see this UI.go is importing some more packages, and all these packages are basically hosted on GitHub. That's the reason why you have the GitHub complete URL. So this is the basic, these are the basics of Go modules and Go packages. So in the next video, we will try to start with basics like understanding Go variables, Go constants, data types, and all those things. Thank you, and I'll see you in the next one.